Okay, so this is a press. I know there's a lot of noise in the background, you've got to tolerate it. I'm going to put a piece of metal in there and we're going to compress it. Buckling looks like. We're going to see this thing buckle. A lot of tension on it, but you see where the moment was on this material side by side. Just about the same area. Now that's a buckle. It buckles out. From there, it is failed. There was some head compression as it compressed down to get its base. The base is actually better. Had a little bit of torque action possibly. Maybe they don't line up perfectly, right? But that's your buckle. We can take it a little bit further and then I'll pull it out. So there's your buckle with it splitting down the middle like a column. The concrete bursting out. Very taut. Very tight. You know, you're not going to pull that out. At some point, it becomes loose and it can break away. You might have missed it. Go. You would think it would still be on the full load, but that's not the way it works. It becomes, how it deforms and no longer can hold, and items can fall through. You know, the roof can fall through, etc. Let's grab. Now we're going to demonstrate punching shear. That's just a piece of steel there, and I'm going to put a piece of plywood on top. Of course, the shape of this, sorry about the noise in the background, the shape is not conducive, but it's good enough. I'm going to place it on top and we're going to work it. Okay, so now we're loaded. Let's watch it punch through from the underside. Or it's going to fracture. I might have missed it. You'll see some of it go through. I got to allow for movement of the product. See, it's punching through on the ceiling, and so that's what you would get. This is going to buckle though. At some point, it's going to be to punch through the floor, this part, but then the rest will start buckling. Okay, so you saw the head peeled down a little bit. That's that metal deforming. I think I'm on top of the flat part of steel, so we won't see. All we'll see is buckling. It's going to transfer one-to-one into the plywood almost, and into that steel. So let's pull it out and let's observe the punch shear that it put inside. Yeah, see the top of it? It's undisturbed pretty much. But the underside, you'll see that it started punching through it. See so it started punching through it, and that would be including this recess here. If I didn't have it at that other piece, we would have seen it go all the way through, and that would have been your punch shear. Puncture shear. Punch shear or punching shear is the base I like to make. Let's get a piece of plywood in here. got a piece of plywood now. We have a piece of plywood. And where do you guys think it will buckle? Where should it buckle? Well, if it's stable all the way down, it should buckle in the middle. It should be an equal compression. The failure should be right about here if it's stable. Let's see if that's true. Or will it take a torque? Or will it take a torque at the top and then fracture like we've seen the metal do a few times? But this is plywood, so it's got multiple layers. I'm going to make sure it stays flat on each side so we're kind of film. See how this works out. And there it is in the middle. Because it's a stable product, your buckling is going to be in your middle. Now which way it goes based on the plywood layers. So there's your buckle. And right here. So this side is your tension side. And this is your compression side. So if we were thinking about reinforcement, and so it wouldn't go out this way, we would put steel on this side. On this side, it would be a strong back, and you would see spalling, concrete bursting out because of the position it's in. On this side, you would see elongation of steel, and your bursting of your steel would be at the furthest point. So let's go back again. So there we go. Now that stayed elastic. So there's elastic and inelastic. That was elastic. It came back to its original form. It's got some little deformation in there, but it came back. Let's load it again a little bit. All right. So again, this is where we would put your steel on this side for your strength. And on this side, well, you're going to be putting your concrete, you're spalling your concrete off. So, it's pretty taut. It's not quite taut because I can still pull it out. So she's still got some flex to go. Now she's done. So that's the maximum amount it will take before it's going to start fracturing right about now. Right about now, she's not allowing me to push either way. So she's going to fracture at this point. And there's the crack. It's right about there. And there's your crack. Right there. So cracks aren't for free, as we know, right? You get nothing for free. And there's the rest of your crack. There's your spalling. And there's your rest of the material. At this point, it's getting a little bit of torque action going on with that, so it's sort of shoving it off to the side. But we'll finish it off with a video content. Now that side's in tension, and that's the compressor side. All right, guys, here's my man. He's gonna come around here with the claw. That thing just grips. It opens and closes. There's shelves going in by way of the trash can. Okay, I want to show you about how basically it's very stable in the position it's in. But once you push it over, it's the joints that fail. So now we push this over. And now you guys see how it collapsed. It's not the same. You just don't get anything for free, as I always tell you. So then we look at this one that I knocked over. And you can see all the members, and you can imagine this is tiebacks, but of concrete. That would have just compressed and broken forward. That column would have just came forward, crushing. There are the cross members. concrete in between it would have been pretty much insignificant, fracturing and breaking all apart. We'll do the one back, a taller one again. Got a shear panel. There's your panel right there. Okay, so we have set up here is just that same column you saw a buckle earlier. Now it's at a plumb. So maybe I can pull it back over a little bit, but maybe it doesn't really matter for my purposes. I want you to look at that. What I did here is I put a piece of just this board on top, and I used a brake caliper for my punching shear product. And let's go from the underside of it, and let's watch as you, let me see if I can shift it over a little bit. Just a little bit, right? Not much. I want you to watch on the underside as the stressors develop and show themselves, reveal themselves. So it's just a little bit of bump. Okay, that's all the bumping we do. You see now the deflection in it. And on top, we get a wave in the deck. We're starting to get a wave in the deck. Of course, this force has more surface area and around the outside than here. So this is where we're going to get our reveal, our punch through. Now I don't want this to fall on my camera because that should slide down and drop. We don't want that on me. So let's do this. Tilt back, and you observe. Let me see if I can get in his path. Right about there. It should start coming down. We've got full punch all the way through now. So that's what it looks like from the underside. Now I want you to notice this is a really slow motion, but watch the wave of the panel up and down and all around as it punctures, as it releases that stress. A wave is created. And that gets us a different wave based on where the different columns are that are supporting the rest of the deck. Watch again the wave. You can slow this down and watch it again. But see the wave that's created? That rocking action. It's not for free. You get nothing for free. See, we've got full punch all the way through now. So that's what it looks like from the underside. From the underside as you look at it. And I'm going to talk to you about more of the reveal in a moment. Let's go ahead and let that cycle. Now obviously I got a load on top, so that's going to want to buckle that. We could have fun and buckle it. Or we can just pull down this guy and reveal it. And you see what that looks like, right? You see that. So you see at the base of these columns, it has the same indicators of puncture, the plywood, how it bent up, the deck reacting to the brake, similar to your column brakes. All right. So this helps you understand direction also of the deck, which way it was coming off, along with the numbers. Saw that now, or you see it. I'm going to talk to you about the profile inside the head of that in a while, but right now I just want to show you that how you get that tearing going on and get you guys thinking about it and how you get the different looks, different particles, rubbing numbers off as it comes down. So glad I'm away for you guys. Hope you enjoy it. Let's go ahead and finish this off in kind of a flappy idea, the wave. So the wave would be, this side coming down off of this one, and then maybe dragging here, and then it collapses. And of course it rips from the deck, from the ledger in the back, against the wall, and it collapses down. All right, let me get back to work. Just wanted to get you some content though. Oh, let's buckle this for the hell. We're here, we're gonna go ahead and buckle this bad boy. So, it's on a slight bit of an angle. I'd imagine I'd want to buckle right about there and go on that. You think. It's a tough call because the channel's different. It's a tough call. So I'd have this one wanting to go out that way, but this one wanting to come this way. So let's see. Alright, so it did go to the buckle at the base. At the base, because the one buckling at the base would indicate that it was longer than the one to the left. So it experienced the lows first. And then on the other one, it's already, I think it's already torqued. Going out that way. You can see based on the U channel, the channel shape of the material, how it wants to buckle on this in this case. Now if you had stirrups on there, those little straps that go around it, that would help hold it in longer before failure. Remember, this is going to become loose at some point though. And in this case, we'll see this probably, oh here it is, it's already loose. This one's under colloding, this one's not. Let's take it, this should drop down. Here we go. We're slipping away and that's going to just about fall off. Let's continue. So now you see some reactions going on. Now, of course, this was a two-sided column that I made for you guys, but just something you can start learning reactions and just start predicting and start figuring out. Okay, this looks more like this. Oh, that might have been up top. It folded there. The loads continued and it just bounced over. But in this case, if the loads are still on it. If this was still on it, it would have followed it down, you would think. This would also probably fracture. We have a crease here. Strong I am. One finger lifted up. Isn't that amazing?